So this is the 2015 Leave Insert Ordinary Level Paper 1, and we're looking at question 9. Amanda buys a new car for €25,000. She knows that the value of cars depreciates by a fixed percentage each year. She draws the graph below to represent the value of her car for the next 6 years. So here we have the value of the car on the vertical axis and the number of years across the horizontal axis. And we can see as the years go by, the value of her car is decreasing. Okay, so A part 1 says use Amanda's graph to estimate the length of time it will take for the car to depreciate from €15,000 to €10,000. Okay, so we're going to, from €15,000 and €10,000, we're going to go across to our graph and drop down some values and look at the time that it took for it to decrease by that much. So from 15,000, if we bring a line straight across, we hit the graph and then go straight down, we hit the graph again here. And then from 10,000, if we do the same, go across, graph there, and then bring it down, and we hit the graph there. So we're going to read off these times now. So here, that there looks like each square here is worth 0.25, so that's 2.25 years, 2.25 years. And this time here, we're going to estimate that to be about 4.05 years. So we went from 4.05 or from 2.25 years to 4.05. So if we subtract them, that will give us 4.05 minus 2.25, 1.8. So 1.8 years is what it took for the car to depreciate from 15,000 to 10,000. We should put our units in, 1.8 years. Okay, so part 2 says continue Amanda's graph to find the approximate value of the car after 7.5 years. Okay, so if we continue the graph on, do this as accurately as you can, as smoothly as you can. You can see there that the graph will kind of continue on along the same lines there. So 7.5 years, if we go up from 7.5 years, which is here, halfway between 7 and 8, hit the curve. And then from there we go across, and we can see that it's worth roughly €5,000. So €5,000 will be the value after 7.5 years. Part 3 says what name is given to the type of curve Amanda has drawn above? Well, a curve that goes down in this fashion and begins to flatten out, that's an exponential curve. This is actually exponential decay, but the curve is exponential. And part B says, on the day that Amanda bought her car, Cathal also bought a new car. His car cost $22,500. Amanda's car will travel 15 kilometers on a litre of fuel. Cathal's car will travel 10 kilometers on a litre of fuel. How many kilometers will the cars have to travel until the cost price of the car plus the cost of fuel are equal for the two cars? Assume that fuel costs $1.50 per litre over the period. Okay, well there's two people here that we need to look at. So we're going to do a split screen here and we're going to look at Amanda first. Okay. Now, Amanda, we highlight her information in one colour. So, Amanda, she travels 15 kilometers on a litre of fuel. And then if we look at Cathal, he travels 10 kilometers on a litre of fuel. Now, Cathal's car costs $22,500, and Amanda's car, which was the original car, cost $25,000. So So Amanda's car was 25,000 euro, and Cahill's car was 22,500 euro. Okay, so if we now try and work out the cost, that's the cost of the car for both. If we can now work the cost per kilometre of the fuel. So the cost per kilometre would be the cost of a litre over the number of kilometres. And the cost of a litre is 150. That's the same for both of them, it's 150 per litre. So we'll put this in cents. 150 is 150 cents, but we're going to divide that by the kilometres that Amanda gets on a litre of fuel, so that's 15. So 150 divided by 15, that gives me 10, and that's cents per kilometre. So if we do the same over here for Cahill, again the price is 150, but Cahill gets 10 kilometres per litre. So 150 divided by 10 is 15 cents per kilometre. Okay, so we know the difference in price of the cars, and we know the difference in cents per kilometre. Okay, so what we're going to do now is we're going to think about what is the cost difference for the fuel. Well, the cost difference for the fuel is cost difference for the fuel is 15 minus 10 is 15 minus the 10. That's 5 cent per kilometre. So how many kilometres would it take to make up the difference in the cost of the car? So the difference between the costs of the car, fuel difference, was the 5 cents per kilometre. The car difference is 25 grand minus the 22.5 grand, which gives us 2,500 euro. So we can see that Amanda has the more expensive car, but the cheaper, she spends less on per kilometre on fuel. And Cahill has the cheaper car but spends more per kilometre on fuel. So we need to see how many of these differences, these 5 cent differences, are in this amount here. So what we need to do then is divide the 2,500 by the 5 cent. Now 2,500, that's euro, divided by 5 cent. So we've got to make sure the units are the same. So that's going to be 2,500. That's in euro, so we've got to put 5 cent in euro, so it's going to be 0.05. And that gives us 50,000. If you do it in your calculator, 50,000 kilometers. So that's how many kilometers would need to be traveled for the cars to be equal in value, including the cost of the fuel. And that's the end of question 9.